Lisa, bonjour. I'm super happy to have you for this data sommelier show. And I've seen you on LinkedIn talking about super hot topic I like very much, metadata, MCP, and I wanted to have you and have this live conversation. And okay, we will do it in English, but I know you speak French, right?
Oui, je parle un petit français.
Ouais, super. But we will continue in English, right?
Yes, please.
Yeah. Yeah. So Gravitino, this is an open source project under the Apache Foundation. It's about managing metadata, and it's very great. And you are here to give us a little bit more about what you do here on this project.
Yeah, absolutely. I can also introduce myself a little bit. My name is Lisa, as you kind of mentioned, and I work as a product manager at a company called Data Strato. And we originally created this project before donating to the Apache Software Foundation about 1 year ago. And really, the motivation behind Apache Gravitino is to have a unified meta store for the open data stack. And it's, very large data architecture. There's a lot of different data sources right now that need to be unified, especially if we want to serve to things like AI. And we'll get into some of those topics later, which is really exciting. And yeah, this is sort of the motivation. But my background is mostly in like open source, the Linux Foundation, and the Open Platform for Enterprise AI, and all of these sort of good things.
Yeah, and today you are in France, and you have attended an open source meetup or forum, right?
Yes, so I'm here in Paris today, having just attended the Open Source Founders Summit. So, really, this is one of the only conferences that I know, and it's hosted by Passport, which is based out of Luxembourg, and Emily Omier. So if you know her, she's very big in the open source community here in France. And it's about the business of open source. How do we monetize, and how do we, really create successful businesses as founders, and, really building out a lot of those things. So it's a very exciting event. Would recommend it.
Okay, so this could be a topic in itself to do. To do. Yeah, good. So thank you. Apache Gravitino. So Gravitino, what the meaning of that? What do you mean behind that Gravitino?
Yeah, it's a very floaty type of term, right? And one of the things that I love about it is it's meant to evoke the emotion of being the layer above, the all of the land, but just before you hit the sky, maybe is kind of the feeling that it evokes. If you hit this QR code, you'll end up going to our GitHub repo. So github.com/Apache/Gravitino. We're an open source project under the ASF Foundation, and the idea of this project is really to be a wide project that can reach a lot of different connectors to underlying data systems, including your large data lakehouse, your messaging systems, your even file sets or machine learning models, and to make it accessible for querying to the query engines, right? And this sounds very simple in theory, but when you think about the federation of the metadata, the management and of the metadata and the life cycles, as well as even just the security and control of enforcing all of this in a performant way, it becomes quite complicated because large data architecture is, if anything, messy. It's never clean. And there's a lot of legacy systems, there's a lot of modern systems that's part of this. So really the point of Gravitino was to create a single unified layer where you can query and access all of your data without moving the data from its source system. So this is supposed to be a very lightweight federation layer. And then, of course, if you're working on multiple cloud providers, which many of us are, like Amazon and Google, and Azure or on-prem, some sort of mix of things, and you don't want to move the data from those cloud providers, and you want to, min max your cost there, you can keep the data there, not have to worry about it. Same with a geo-distributed system. We maybe have data, in different data centers across the world. We don't want to move it for compliance issues. And Gravitino offers, it's written in Java, and some new components have been written in Rust as well. But we offer a very API-driven interfaces, including Rust. We offer a Java and Python client and a full CLI and a GUI as well. And really, this is supposed to be the layer for all of your data governance, right? To kind of float off of and be enabled in a really API-driven way. And yeah, it's under Apache 2.0, and I'm happy to talk more about it.
Yeah, so it seems easy, but it is not. We have tried for decades to resolve this, right? I remember my time at IBM, that was more than 20 years ago, and we have got this hub and spoke architecture, collecting metadata from different systems, then trying to centralize everything in one common hub, and it was working, but it was hard to implement, right?
Hmm.
Was batch oriented, and the purpose of metadata is to be accessible in real time, right? We need to have the vision of the ecosystem in real time, not in batch. So this is a complex system to resolve, right?
Absolutely. And previously, when we thought about large data, we thought about ETL or ELT and building single point to point pipelines. And a lot of that was meant to serve data to very specific use cases. Now we have a lot of different data that's meant to serve multiple use cases at any given time. So we have large relational stores that are meant to serve to AI systems, but also large amounts of unstructured data like images and audio files and whatever you have. And then also messaging systems. So you have real-time data, very small pieces of data that are generated as well. And then your data sets and your, feature stores and all of these things. So all of these things are feeding into ideally AI systems at this point, but also just normal like analytic systems as well. And so the silos that we create as a result of building point to point pipelines can be very punishing. And so, how can we at least remove some of that upfront work that we have to do to make more flexible data architectures?
Yeah, and you have started a few months ago, right? It's still it's a new project and a young project.
Yeah, so it's under a year old. I think we entered into the Apache incubator about 8 months ago, but we're about to graduate as a top level project, which is really cool announcement to be part of this podcast. And next week you'll see some of the announcements come out around it.
So congratulations for that.
Thank you. It's been a wild ride for sure.
Yes. So what was the original idea? Why did you decide one day to write this?
So really the motivation was when a lot of the large data architectures were trying to move away from Hive Metastore and sort of like this very heavy Hadoop ecosystem that a lot of people were coupled to, but also bringing in new different types of open table formats to work in congruency with them. Like Iceberg is probably the really big one that a lot of folks know these days. But generally speaking, there was a lot of vendor lock-in also going on at the time between, having your data locked behind Amazon or Snowflake, and it was very hard to work around all this. And so an open solution needed to be developed that was truly vendor neutral so that people could control their metadata. Many people don't think about this exactly, but metadata is actually the single point of vendor lock-in for a lot of different places because metadata is so powerful, right? Including like in all of your cloud provider ecosystems. And so if you can regain that control of the metadata, you can make migrations much easier. You have interoperability between all of your different systems, et cetera, et cetera. So it's really important to be able to reach that.
Yeah, and yeah, we will conclude with this MCP and semantic layer question, because I keep question for you for the end. But before doing that, we plan to go through different slides to understand the architecture and the concept of Gravitino, right?
Yes, and I'm happy to do that just to explain to folks a little bit what this project is really about and what it looks like. So one of the things that Gravitino is often called is a meta store or a data catalog. And I think typically when we think of data catalogs, it's around a traditional business or data product catalog where we have like maybe a marketplace and our business glossary and all of these things. But a technical data catalog, also known as a meta store, typically refers to all of the metadata that you'll pull from your different pieces of data and underlying systems, so your data files at the very technical level. So maybe the partition data, where it's stored, the access control around it, maybe some of the statistics around like what files or what schema is contained here and things like that. Things that are very important to know for the query engine to be able to do its job
Yes.
efficiently, right? This is very important. And that's what we consider the meta store. And so it's a very technical layer there. And one of the things that the open data revolution has kind of helped facilitate when we think about the open data architecture that's emerging now is we're thinking about all these open source engines being able to access all these open table formats and all these other data formats as well. And so it's really important to create a layer in between there. And a lot of people think, okay, I have a engine like Spark, and I just query my tables, and that's it. But how does Spark know which tables to query and what the efficient way to do it is, and how do we grant access to Spark to access certain tables? And that's where the catalog comes in, and that's one of the things that we're really passionate about. And so if you want to break down some of those silos and grant access control, but also enrich that metadata for things like lineage, for things like data governance, search and discovery, this is where data catalog comes in. So that's kind of, listing why the data catalog is so important. And we don't really have, ideally Gravitino will be it, but a true open data catalog that can reach the entire ecosystem for all of these different engines. And I mentioned Spark, but we also have, new waves of different access from the Python ecosystem as well, including PyTorch, Ray, Daft, as well as like MCP now. So there's a lot of different things that the catalog needs to power.
Yes, exactly. Yeah, very clear. Okay. I was curious about a word I've seen about the geo distribution or the
Mhm.
capacity to geo distribute your engine. Maybe you should focus a little bit on this part.
Yeah. So one of the things that's really tough is figuring out joins between data that's stored in different regions, right? And one of the amazing things about the EU is that privacy is very important, which I love. But it also makes it complicated from a technical perspective to be able to
Yes.
access all of this data. And so if I say have a Trino cluster and I want to query data that's stored in the EU and in Asia and in America, but I can't physically move that data, how can I actually access and perform that join? So there's two strategies here that Gravitino implements. The first is a virtualization strategy. So by virtualizing the metadata, you're able to have Trino, do that federated join without necessarily having to do that specific uh, process, and it'll be much easier as well. And then one of the other things that we'll have to be able to do as well is actually cascade the connectors if we want something that's more performant. So if you're doing just the virtualized metadata strategy, that'll be pretty easy to do natively in Gravitino, but there's also a separate Trino cascading connector that we have as well. That's also open source, where you can have the Trino instances talk to each other and coordinate that join as well without having to move the data, and they're able to work in isolation, but you still get the same effect. And from a user perspective, it's all the same.
Okay, good. Understood. It's very clear. So it's multi-cluster, multi-region, multi-domains, or yeah. Okay.
Yes.
Okay, I can see here the that data engine. So you have Spark, Trino, and many others. And Gravitino is in the middle of your ecosystem, right?
Yes, and one of the things that makes Gravitino really interesting in terms of the project that it has is that it's a very wide project, like I said, and it doesn't just act as a data catalog for a single point. So if we took like Hive Metastore, Hive Metastore is a catalog for specific Hadoop-based data lakes, but you also have like say JDBC catalogs for your relational stores. Like if you're using Postgres, for instance, or MySQL, you'll use the JDBC catalog. If you're using Kafka, you'll have a separate schema registry. So all of these are separate, analogous, and parallel catalogs that were not previously joined before. And so it became very hard to do this like cross functionality. If I wanted to say implement some sort of access control rule or policy, I would have to do it individually in each one of those layers and verticals. And it's very painful and non-scalable to do it that way. Whereas if you do use Gravitino, you can have a layer that ingests from all of those catalogs and manages all of those catalogs. You define the policy in Gravitino. The query engine accesses Gravitino specifically, and then everything else in terms of policy and access management is pushed down to the underlying systems. So the user experience is much easier. The infrastructure team only has to worry about one thing and managing that one thing, and then everything else remains the same. You don't have to really do that much else in terms of migration.
Okay. So how do you collect automatically the metadata from the different sources? This is a specific mechanism, or this is pull or push, or it's a combination of
Yeah. So
techniques?
you can define some of that logic more customizably, but the way that we do it is that we pull from different systems as
Okay.
well. And so you can implement more of a push-based system. It kind of depends on the catalog that you have, but generally you're going to have a very consistent catalog of catalogs model. So if I went into this slide, which is the Gravitino architecture, the meta store is there sitting on top of the different catalogs that we implement, and then we convert all of the catalogs that we have into a common schema or data model that we all can appreciate in Gravitino as being like the standard. And that is taken from the underlying systems as well. So hopefully that makes a little bit of sense in terms of how we ingest different catalogs. The way that this maybe differs from other catalog systems is that a catalog system will define its schema in a little bit more of a stricter way, or maybe not. Maybe it's just a complete nightmare, but it will do it from scratch externally. And that's very hard to be able to manage multiple systems. That's why they only do point to point, right? Whereas the Metastorm model is much more flexible. And because of this, you can define a lot of custom logic in terms of how you handle that, which makes it really great if you're working with a really large data infrastructure. And then, you can define what type of metadata store backend you want to be able to store that data in. And then using Gravitino's REST API, or you can even use the IRC as well, which is the Iceberg REST catalog. You can query and access that data, make your calls to it, and then have an API-driven way to do the things like data platforming, the governance, the lineage, and your access control management.
Okay. So until now, it's mostly technical metadata, right?
Yes.
And do you plan to add more business-oriented information in your system?
So there is the ability to create your own custom metadata fields as well. And one of the visions that we have, at least for more of the enterprise offering of Gravitino, and I think that one of the reasons why this is because it's very hard to kind of create a self-serving system that's very polished, like what a normal data consumer would expect, just purely in open source. So if you have something like that you want to use the Gravitino backend for, you can plug it in. But for us, we plan to be able to have all of that extensibility and pluggability also include the business side of the catalogs as well.
So yes, so this is a good time to say that you have an enterprise version, right?
Yes.
Offering much more features, and this is a standard way to share open source technology, right? You have the core, and
Mhm.
you have some extensions on top of that.
Yes, and the best way that I would describe the difference is that if you have a very competent team that just needs that Gravitino layer to plug in, and you already have an existing architecture that has maybe a lot of like in-house data platforming that you just need to have connected to your architecture, that's where Gravitino is a really strong component, and everything's open source. So, the community is very prolific at this point in developing different features. But if you want kind of just to create a data platform from scratch or a data fabric from scratch, and you don't want to think about plugging it into anything, you don't want to stand anything up yourself, that's when the enterprise version is a little bit more appropriate. And some things that we include in the enterprise version as well is like, a connector to or an embedded Marquez version, which is one of the interfaces that you can have for Open Lineage, for instance. And like it's got a nicer GUI, it's got more search and discovery features, it's got a lot more things that can also allow you to connect to proprietary systems that can't necessarily go into the Apache license in the open source.
Mhm.
And generally speaking, it's like a little bit more geared towards having a fully fleshed out product with very specific, needs that the enterprise needs in terms of like, we need very specific security requirements, and we need to have SLAs and all of these things that enterprises care about, but some engineering teams might not necessarily need.
Okay, good. So let's zoom a little bit about Iceberg. We started to talk about Iceberg 3 years ago in France,
Mhm.
inviting people to our meetups, and I'm very happy now to see that this trend 3 years ago is real. I mean, it's real implementation. Yes, we can. It's widely adopted. So maybe you can zoom a little bit on Iceberg.
Sure. So this is kind of like some of the stuff that we've talked about around, Gravitino already, but I'm happy to move on to our iceberg stuff. The only thing that I would add here is that if you're looking to have like the like authentication and single sign-on and stuff like that. That's something that Gravitino is really useful for, including for Iceberg, right? So Iceberg's one of the catalogs that we do support, and we actually were one of the first projects to be able to deploy a modularized standalone version of the Iceberg REST catalog. This was kind of before Polaris came out and before Unity, and everybody just started adopting it. And so we're very proud to be able to make that claim to fame for the IRC service. But generally, we also support a large number of catalogs as well beyond just Iceberg. But that's kind of one of the exciting things, is that if you're using Gravitino, you can use the IRC that we have, which is the Iceberg REST catalog, alongside the other catalogs. So it's actually something that you can, cross query your Iceberg tables with and cross manage your Iceberg tables with, instead of just the Iceberg tables themselves. So for those of you who don't necessarily know about the Iceberg REST catalog, generally speaking, Iceberg as an open table format has grown in such adoption, but the catalog itself that comes in the vanilla version of Iceberg, or at just its base level, it's pretty bare bones. Like, it's not really meant to be like a governance tool. It's just meant to kind of help manage and point to query engines to the Iceberg tables and all the metadata files, your manifest lists, etc. And so if you want to build on top of that and actually implement the service, have it implemented Iceberg REST catalog, you need to kind of build that yourself. And previously with Iceberg tables, we would kind of use different catalogs to manage those Iceberg tables. So one of them was Hive Metastore as a catalog, JDBC as a catalog, all of these other things. But it wasn't necessarily easy to use these catalogs, and there was a lot of different issues in terms of like locking, inconsistency issues, conflict resolution, scaling issues. And so you would get a lot of headaches with trying to deploy this at scale. Eventually, what ended up happening in the next couple of years, and the previous last couple of years, is that we've decided to move towards REST. And so what makes REST special is that it's pretty standard, right? I think we all know what REST is at this point. But instead of trying to change the catalog itself from multiple sort of parallel sources and ways, and in like a concurrent way, instead what we can do is just make a call to a server, and then it either accepts it or it doesn't, right? Either, you either get a rejection or it just kind of like does its thing. And that's kind of one of the things that was really nice, is that you moved all of that logic to the server side. And when you move that logic to the server side, you're able to handle all of those calls in the way that you need to be able to work with that. And make it a lot more scalable. You make it much more cleaner. You handle a lot more of the issues that maybe were present in previous implementations. And so the Gravitino Iceberg REST catalog is modularized, but you can also deploy it in Gravitino. But one of the things that makes it really interesting is that instead of just having a REST catalog that you use to manage your Iceberg tables, you can actually propagate or proxy those calls to other catalogs as well. So this is kind of the reality, right? Is that, okay, we have a new catalog. Let's all move to the new catalog, and let's forget that the old catalog exists. But let's be honest, we're probably still stuck with the old catalog as well. That's just the reality of working in large data infrastructure. And so a change that you make with the Iceberg REST catalog in Gravitino can also be translated to Hive catalog as well, or JDBC catalog, or a custom catalog that you have.
Okay. It was a little bit confusing the last few months about understanding who can do what in terms of how to access Iceberg. Some engines are read-only, some others can read and write. So not easy for us to understand and to have the global picture. So what's your recommendation here, maybe?
Yeah, I would say stick to the most popular query engines. The nice thing is that REST is pretty well supported across all of the query engines that we're using, so Flink, Trino, Spark. And so the catalogs will vary in terms of, like, let's say if you're using Polaris or Unity or, all these other catalogs, including Gravitino, the read and write operations when they first came out were not necessarily consistent between all the different engines in terms of what they were capable of doing. The nice thing about Gravitino is that it's pretty well documented what you can and cannot do, but generally speaking, all operations are supported with the Iceberg catalogs. The only time that it will kind of have a little bit more like spotty coverage or more limited operations is if you're like cross-joining or you're using it with another open table format, like Hootie, for instance, right? And so, but generally speaking, I think everything's very well supported. And this is kind of the point of Gravitino anyway. So
Okay, good.
yeah.
I have a feeling that sooner or later, the complexity of Iceberg will disappear. It will be completely embedded in application, and we will talk to Iceberg like we talk to, I don't know, Oracle database.
Yeah, that's definitely the idea, and one of the value props of Iceberg itself is sort of its simplicity, right? Using this metadata layer that's very easily understandable on top of like all these complex data file systems and maybe Parquet files that you don't have to necessarily do yourself. But ideally, nobody's directly working with Iceberg tables. You're obscuring that even further behind another layer, like you're saying, and a more standardized interface.
Yeah, good. So let's go one more slide. Yeah,
And so, with the IRC, we actually do extend out a little bit some of the features that we have to kind of make the data management experience of Iceberg tables a little bit better. So, some of the things that we do is that we have a pluggable and extensible listener system. So, all of the events that you have pre and post Iceberg table operations, including other operations in Gravitino too. I won't get into them too much, but there's a lot of events that you can implement and listen to. So you can actually use that to monitor your Iceberg tables and actually track maybe some of the optimization bottlenecks that you're having in your system, some of the things that are really slow. You can also have dynamic configuration of the catalog. So instead of defining a single catalog to proxy, you can just have it refer to whatever Gravitino is using, which is cool. And then, of course, Gravitino, because it's a really large framework, has very rich audit logs and the discovery and the data lineage that's working with Open Lineage currently. But I think one of the more cool things about Gravitino is that it has a very rich security focus. And so, if you want to do credential vending, for instance, and you want to, do some sort of token vending or issue tokens to the query engines that are temporary, you can do that in Gravitino. And so that can also work with multiple cloud provider systems as well. And that's something that's really cool. So you can have them expire and you're not just giving everybody access to all of your Iceberg tables at any given time just because you decided to do that. We also have OAuth 2 support and extensible support as well for security. So we use Ranger under the hood. Kerberos is only available, of course, for Hive, but generally speaking, we also have an RBAC framework as well that we use. And you can define the roles in Gravitino, and you can also have policies for path-based or SQL-based policies. But one of the cool things is that it will actually push down to an underlying system. So let's say I have Iceberg tables stored in like AWS that uses IAM. I define the role and define some of the access that I want and the groups in Gravitino. It will translate to the IAM system underneath, and you can have that for multiple systems too. So you have Iceberg tables in multiple places, which is very likely. You can then have the access control be consistent across all of them, which is really awesome.
okay, so this is the core of your enhancement, but and I think this is where I can see the benefit of being an Apache part of Apache Foundation, right? Maybe you can share or get advice from different people, organization, or other people about doing the right things and sharing with the community.
Yes, absolutely. And it's a community project, it's a global project, so anybody can contribute to code and become a committer or make their way up to PMC if they want to. That's the whole point of being vendor neutral, is being able to support such a wide system, and it needs to have the community to be able to pitch into it because it's such a large project in a lot of
Yes.
ways. And so there's no way that one single vendor would be able to maintain that.
Okay, so I still have the feeling that sometimes it can be very complex to manage metadata
Mhm.
for different reasons. But yeah, of course, we have a nice GUI on top of that. But at the end, what we want to do is to talk to our systems, right? And
Mhm.
just query informations and and get a result as fast as possible, right? And this is maybe a dimension that is completely new. And I love this topic. It's MCP and what you can do with MCP, collecting metadata, but also creating this semantic layer that is really important to talk to the machine.
Absolutely. And when we look at all of so for those of you who are listening but don't know, the Model Context Protocol was released by Anthropic back in January. And this protocol has now been adopted as sort of this, API spec that then data systems can use for agents or LLMs to directly access context that's stored. So different examples are like Google Drive MCP server or like an Airbyte MCP server. And one of the issues with having like a point-to-point MCP server is that you're only serving context for that particular thing, right? For that particular ecosystem that you're trying to connect to. And so one of the questions that we had was, well, that's useful, but it's not as useful as just being able to connect your entire data lake, right? Like that sounds kind of like MCP on steroids a little bit. And so let's say we do stand up an MCP server with Gravitino, which is something that we actually have been able to do luckily, and this is kind of the blog post that I'm showing here. Can you be able to actually securely implement an MCP server and be able to have, let's say, an LLM or an agent work with these large data systems with the RBAC and the governance and all the things that we've talked about in mind? Because the idea behind MCP was really cool. It's a service mesh idea. But generally speaking, it's made by machine learning engineers who maybe don't have security always at the top of mind, which is a little crazy because if you think about service mesh, you think about platform engineering, which usually has security top of mind. So we do. Here's a blog post, and you're welcome to take a look at it. If you Google Gravitino MCP, you'll find our GitHub repo that's public, and we recommend that people use it for things like table maintenance and data ops. There's some really cool things that are covered in it, such as using MCP to grant or access the data catalog, right? And do your access management and be able to ask really cool questions.
Yeah, and this is surely the next big thing in this data catalog space, creating this clever semantic layer and um, very accessible, very easy to use. And surely this is the next step. I strongly feel like that.
I completely agree. So I actually just found out yesterday, but at Community Over Code North America, happening in September, and also if you're in the Bay Area, AI by the Bay, I'm going to be giving a talk called Catalogs as Context. And really the idea here is that to serve context has previously been a very heavy lift, right? You have to, process all of this data, and then you have to pick out these features, and then you have to feed it, and you have to do this monitoring cyclical process. And can we use metadata in this case that's managed by the catalog to be able to efficiently serve and point context to like whatever agent system that you're using while still retaining security? Because that's one of the big value props of a catalog, is to be able to define provenance and ownership. And so this is really cool, and you can implement your tagging there as well to be able to point to the data agents, go, hey, use this specific tag data for this specific thing. Don't touch anything else. And we can actually enforce that. And it's not a false positive because you're doing it through the data catalog, right?
Yeah, very, very interesting. Yes, and this could be an episode 2 on this specific topic, because this is, to be honest, this is early stage, right? This is
Mhm.
day 0 or day 1 of MCP, and yeah, we have a lot of things to learn and experiment before getting to a conclusion that it works very well.
Absolutely. And one of the things that I think we will be very punished for is not doing it right the first time.
Ex-
This is something that I think is one of the very few, like sometimes you have more forgivable pieces of data that we can work with ahead of time. But I think MCP has caught on so quickly and so fast that if we don't really try and slow down and really implement it correctly this time around, we're going to be in a world of hurt in a few years.
Yeah. So thank you, Lisa. Thank you for this brief on what you do, your product, and enjoy your stay in Paris. And maybe we can conclude in French. I don't know. Merci pour ta participation.
Merci beaucoup. Yeah, je t'aime la Data Nosco et le Data Community en Paris. Yeah, j'écoute. Il y a beaucoup de practitioners
C'est
ici
vrai.
en France. So, yeah.
Merci, Lisa. And talk to you soon for this episode 2 on MCP and the semantic layer.
Thank you very much. Thank you for having me.
Thank you. Bye bye.